Okay, it's Mr. Hunt here with Transformations Review. Let's jump in. On number one, we're going to find, I want you to list the coordinates of the vertices of each image. For number 1A, that's saying right 4 down 2.5. Another way I could have written it is like this, x, let's go back. There we go. 4 negative 2.5 like that with the t. So I'm not going to graph it, but if you go right 4 down 2.5, you should be at 2 negative a half. A prime 7 negative 2.5, t prime 4 negative 6.5, and h prime 0 negative 4.5. Okay, for B, same thing. I'm not going to graph it, but dilate by a factor of 2. And so you just have to get each of the coordinates and multiply by 2. So for example, m is negative 2, 2. That becomes negative 4, 4. Then we have 3, 0. For A, that becomes 6, 0. T is 0, negative 4. Multiplied by 2, 0, negative 8. And by the way, this is around the origin. It'll tell you if it's not around the origin. That would be different. Negative 4, negative 2 becomes negative 8, negative 4. Moving on, you can stop the video if you need time to think about it. For 2a, y equals x is that diagonal line. We're reflecting over it. So you need to take each of the points, for example, negative 2, 2. And the rule is yx, so you're really just flipping them. 2, negative 2. Okay, each one you're just flipping them. So originally, I don't know if I can get these exactly right on here, but it was like this. It might be a little off on the grid, but negative 2, 2, which was this one, I'm way off, sorry. Negative 2, 2 becomes 2, negative 2. So I can change that. Okay, down here. I'm probably just going to write the points and you can check them on your graph. It's going to be a little bit easier that way. So 3, 0 became 0, 3. 0, negative 4 became negative 4, 0. And negative 4, negative 2, negative 2, negative 4. Okay, let's go on to B. Rotate 90. That's negative yx. Is that rule? 270 would have been y negative x. So if I apply the rule to all of them, here are my new points. 0, 3. 3, 0 became, well, negative 0, 3. Negative 2, negative 2. 2, negative 4, and 4, 0. So I'm interchanging and then switching the sign of the first one. So like negative 4, negative 2 for this one. Switched them, became negative 2, negative 4, but then I got to change that sign of the first one. Okay, and you can graph those 4 points. And finally, for this 2c, rotate 180. That rule is negative x, negative y. So you're just changing the signs of all of them. So our new points will be negative 3, 0. Still 0, 4. 4, 2. And then 2, negative 2. Let's see if I can plot these better. 4, 2. That's supposed to be a negative, sorry. 2, negative 2, 0, 4. Negative 3, 0. So then, what is it? Reflect over y equals 1, and that is a horizontal line at 1, right? It says go to the y-axis at 1, which is right here, and you're going to make a horizontal line. X equals a number, it would have been a vertical line. Okay, and so then this is just counting. I mean, I got to take the 1 unit there, so then 1 unit up. I'm having trouble seeing it. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3, 1 unit, and 1 unit. So flipping over that line. Okay. I am noticing on my online or on my answer key, I don't think I did the rotate 180. I don't think I reflected over y equals 1. I did on the video here. Okay, 3a and b I'm going to kind of skim through real quick, but when you read through 3, try out a point. That's what I said. On my key, I just tried out the point 2, -1 and applied the original transformation, dilate by 3, making it 6, -3, and then moving up 6. And if you need help, plot it. I think I was a little off there. Plot it, move up 6, find your point, and then 6, that's 6, 3. It's also just moving the y coordinate plus 6. Okay, and then try A through D and see which one works, and it's going to be D. See which one gets you the same thing. It's going to be D. On 3B, you could try a point, but really you just got to think about, okay, you have an XY point, and they do 2 transformations. They reflect across the line y equals -x. So I just want to know, what's that rule? And that rule is that it does this. It interchanges them and makes both of them negative. -y, -x. Then you're going to go S right. So you're going to go right, so that's plus S to your x coordinate. Even though your x coordinate is now a y, but it's your first coordinate, right? Plus S. And then T down. So you take your -x, which was there, and down is your y movement, your second coordinate movement. And so it's going to be down -t. So that's B. Okay, on 4, you're going to need to graph the 2 triangles. And I'm just going to make a quick sketch of what you'll get. Okay, you get a bigger triangle and a smaller one here. Okay, it's just a brief sketch. You can look at my key. But graph the 2 triangles. The scale factor, you can just do some counting to figure out the scale factor. So when you look at like over and down for a pre-image and image line, here's what I did. I saw that this was over 3, down 3, and this was over 9, down 9. And we're starting with the geo. The smaller triangle is the pre-image, so that means the bigger triangle is what we're going to. So we're dilating by 3. So that's the scale factor, 3. If we're going big to small, it'd be 1/3. Okay, and then as soon as you draw in the lines, so if you connect a pre-image and image line, points, you'll be able to get the point where they intersect, and that will be, so you get that point, and that will be the point of the center of dilation. I'm actually pretty close there. It's 2, 9 when you draw it in. Okay, on 5, which of the following would map onto itself? Now, that has to be congruent, map onto itself. It has to be in the same spot. It's mainly a question about symmetry almost. So even though any translation, reflection, or rotation would be a congruence transformation, this says onto itself, so it has to be in the same spot. And you just try all these. The first one is going to be good. A is going to be good because it's the same units. It's 4 units here and 4 units here. So if you flip it over the y-axis, it'll be good. Y equals x. It's not a square. If it was a square, it would have been good, but it's not going to be good there. Rotating 90, that would get you. It would be, let's say, is it around the origin? It'd be like that. So it's a congruent shape, but it's not mapping it onto itself. Let me jump down to the E though. If we rotate 180 though, we would be back at the original. We'd be halfway around, which would be the original shape. F was supposed to be y equals -x, which would also not work, and D, x-axis. Flipping it over here would also, because these are each 3 units, yeah, it will be symmetric, so that will work. Okay, 6A through C. Depending on what figure you start with, answers may vary. I started with triangle ABC for the first one. Some of these you're just going to try it out, see if it works, try something else if not. But if you take triangle ABC, I'm just making a quick sketch. This one, that's actually more like that. If you reflect over the x-axis, it'll be lined up nicely down here. It'll be like that. Ooh. It'll be like that. So if you reflect over the x-axis, it'll be good. And then you go right 3, up 1. Answers may vary because actually on mine I actually said to go right 3, down 1, and then reflect over the x-axis. So there's different ways to do it. This was A. Go ahead and look at the answer key for B. I'm not going to go through all of these here. 6, let's go to C. The thing about this one I want to say is it's clearly that we have this little triangle. If I get it here, there we go. Little triangle and a bigger triangle here, not to scale, I know. So I look at this length and this length, and I say I know I need this is 3 and this is 6 units. So I know that I need to dilate by 2 if I start with the smaller one. If I start with the bigger one, I dilate by half. So I dilate by 2, and then I actually get a nice figure like that, and I can reflect over the x-axis. Okay, 7, you just got to try out each of the points and go through and see those 3 transformations, which one works. Okay, I'm going to go ahead and just do the, it ends up being B here. So when you take 1, -1, and you reflect over the y-axis, it would be, if I get it right there, -1, -1. So originally it was that. Then I go left 3, up 2. 2, 3, up 2 would be right here. 1, 2, 3, 4, -4, 1. You don't have to list these, you just need the final one. Dilate by 3. So then dilating by 3, we multiply each of these numbers by 3, you get -12, 3, and that works. The other 3 would not. Okay, moving on to number 8 here. I'm hard here on the line tool. Number 8, graph the points, rotate the triangle 270 counterclockwise, about 1, -2. I already plotted 1, -2. So here's what we need to do. We need to draw in, if I get it here, new axes along that point. All right, and that's our new origin. And then you just do everything as normal. You got to relabel the points, though. So let's see, back to this. There we go. 2, 4 for that one. 0, -4. -3, -3. Okay, I rotate as normal. So let's change the color here. So I rotate as normal. The rule for 270 counterclockwise is y -x. Let's see if I can write that over here. Y -x. So this one, I interchange, -4. 0, I can't change 0 sign, so just that stays the same. 4, 2, change the sign of the second one. -3, -3, but I change the sign of the second one to positive. Okay, so I plot those on my new axes here. 1, 2, 3, 4. -3, 3. 4, -2. I'm not going to require you to write the new points, just graph. That's it. Okay, I'm moving right along to B. Same idea. So that was A right there. So let me separate it. I'll go up here. This is going to be B. Notice 270 clockwise is the same as 90 degrees counterclockwise. So part B, we're going to do -yx for the rule. Okay, negative 3, 5. I'm going to try and use that the forest green. 1, 2, 3, 4, 5. Triangle, that's the original one. I'm still going to use that one. All right, so we're going to rotate around that point. So now I need new axes. Let's go here, around that point. Nope, not working. Close enough. Okay, negative 3, 5. Yeah, and so it's the same idea. I just need these points now. So I'm going to write what the forest green triangle, those new points are, be 6, negative 3. Okay, I see what I did actually. I'm sorry. I was starting to label those. I'm sorry, I put my one mistake here. There we go. I put the point. This is why it's hard to overlap these. I put the new point of rotation in relation to that orange axis. That's the wrong one. So go back to my original axes here, and I do negative 3, 5. 1, 2, 3, 1, 2, 3, 4, 5, right there. Okay, that's what we're rotating around. So then I can draw this in here. Oh, nope. There we go. Right there. Now these points should make better sense. Okay, so now this point is going to be from that new origin, 6, negative 3. This one down, let's see, let's go to this one next. This one, 1, negative 10. And this one down here as 4, negative 11. You can count those out if you wish. We really should try these first and then check it over. So the new coordinates I'm going to write up here, 3, 6, 10, 1, and 11, 4. After I do the rule, down here. Up here. Negative yx. Okay, and so then I plot these. I'm getting low on time here. 1, 2, 3, 6. 1, 2, 3, 1, 2. Okay, of course from my new origin. 10, 1, and 11, 4. 10, 1 would be right there. And 11, 4 would be right there. So there's our new triangle. Okay, moving on to number 9. Number 9, let me set it up real quick. Okay, dilate part A. This triangle sun, by 1/2, half as big, about the point negative 5, negative 7. 5, 1, 2, 3, 4, 5, 6, 7. Down here. All right, so I'm just going to show you one, and then we'll get the rest of them, but the same idea. By the way, again, you can do this if you want to draw in a new axis, relabel these points as whatever they are, and then just, times it by 1/2. Totally work. My other method I feel is a little shorter here, is I just count over and down. So it looks like, let's make sure I'm counting correctly here. 2, 3, 4, 5, 6, 7, 8, 9, 10. Like this one was the 11 and 6, 7, 8. Okay, so you could say up 11, right 8, or really from our point, left 8, down 11. Half of that, right, we're doing D1 half. So you go left 4. I'm starting here. 1, 2, 3, 4. 1, 2, 3, 4, 5.5. So I went half of 8, which is 4, and half of 11, which is 5.5. There's my new one. Okay. You do the same thing for the other two, and you get 0, 1/2, and then 1/2, negative 4.5. So the first triangle looks like that. Part B, we're dilating by 2.5, about the point 1, 0. So close to the origin, but a little bit off. 1, 0. Here's all I do. I'll do 1 again for this. So I'll do this bottom point here. I count again. Drawing in a new origin thing would totally work. I just count right 5 down 2. Okay, right 5 down 2. Multiply that by 2.5. Right, and 2 times 2.5. So you're going to get this one's 5, and this one is 12.5. So I go right 12.5. 5 down 5. Should be right there. Okay, and if you do the other two, this one is somewhere, it's quite far up here. I don't know if that's exact. I'm running out of room. So, but it looked like that. Yeah, sorry, they are a little bit off your paper, but you can still count. Last page, going to finish up real quick. 10. Again, read through these real quick. I'm just going through the answers. But it talks about the triangles, and you're taking one triangle and dilating it in 2 different ways, by 1/2 and by 3/4. Well, it doesn't matter what you're dilating by. All of the triangles will be similar. Let's be semi-similar symbol. Right, they're all going to be similar. One's small, maybe one's a little bit bigger, one's even bigger. They're all going to be similar, though. All the angles will still be congruent, the ones that match up. Okay, so angle tells us that the triangles must all be similar. All right, the angles are still congruent. So doesn't matter that's different scale factors. The answer is A. All are going to be similar. 11, you have a line as a slope of 8, y-intercept of 5, 0, 5. And it's a result of dilating line P by a factor of 3 with center 0, 3. Now that's important. 0, 3. All right, we know they're going to have the same slope, right? We've talked about that. You dilate lines, they have the same slope. So if the first one has a slope of 8, we can eliminate D and A because they have different slopes. It's either B or C. And we're dilating by 3. Well, we can just, again, dilate this point. It's got to be twice as far away. You can do the new origin thing. That'll still work. All I'm going to do, though, is say that this distance is 2, and we're dilating by 3. So that distance really needs to be 6. So I go up 1, 2, 3, 4, 5, 6. Did I get that right? 3, 4, 5, 6. Yeah. So right there. So that y-intercept is 9. So the answer is C. Okay, for time's sake, I need to keep going, and I'm going to skip over 12 and 13, but they're actually kind of similar to some of these other ones. They're good problems. 12 is A and 13 is B. Let's finish up with 14. It's a regular octagon. And let's see, F. They just say which of the following will map onto itself. So it's congruent, but it also must match and lie on top of the other one. Okay. So if we reflect over QV, let's see if I can get this here. 1, 2, 4. Let's see if I can get close to an octagon, right? Pretty good. So if we reflect over QV right here, will it map onto itself? Well, yeah, it'll be the same. The lines affect it, but certainly that one will be. What about RW? Let's see, right? That'd be those two. Yeah, same thing. Right, that works. What about TZ? Right there. No, it wouldn't match up. So that one doesn't work. Okay, then what about rotating? Now, first of all, rotating 45 around point Z. Well, a rotation will create a congruent shape, sure. And a reflection will, and a translation will. But if I rotate around point Z, clockwise, 45 degrees this way, this octagon is going to be like here. So there's no way it's going to be in the same spot or location. So this one is out. Okay, then what about rotating 135 and 90 around point C? Now point C is the center, so that's good. Do those angles work, though? And here's what we know. Regular octagon, the rotational symmetry order is 8. So if we divide 360 by 8, we get, run out of room, 45 degrees. So that means each turn, 45, 45, each time it takes 45 degrees to get to the next spot. Well, what does that tell us? It means it takes 45 degrees to match it up going to here. 45 again, 90. 45 again, that's 135. So E does work. And we already overlapped with 90 degrees, so F works as well. Thanks for watching. Mr. Hunt here, signing out.